adding trivial new functionality to the Linux kernel for the benefit of the community. In other words, if you find yourself that with a piece of hardware that everything in the hardware is supported in the Linux kernel, but the hardware itself as a whole is not, what do you do? Now, here we have a blue screen. And, oh, I should probably have booted into Linux first. Now, the example hardware that we have tonight is a video capture card. Now, there are various very common video capture chipsets in use. And this piece of hardware indeed uses one of them. It's a chipset from Connexent. And it's a chipset that is well supported in the Linux kernel. Slight bit of history. About a year ago, I picked up a card that uses this chipset because I knew the chipset was well supported. And I tried it under Linux. And I found that although the chipset was well supported, none of the known cards that use this chipset, known to the Linux kernel that is, none of them were similar enough to this one that telling the kernel that this was one of those would work. And so what I did was what we're going to do tonight. And the difference tonight is that this is a different card. But the card that I did this with before uses the same printed circuit board as this one, apparently, yet comes from a different vendor. So there will be similarities, there will be differences. Now, the first thing we're going to do, as you can see, the distribution currently installed is Citrix. Now, in Citrix, there is a shell script that is installed by default that will go out and it will fetch the kernel sources for the kernel version used in the distribution, and it will patch them with the patches used in the distribution. Now, first, of course, we will need internet access.
What is the distro you have there?
Citrix.
Okay, so the way that you just described that was a little confusing. You said Citrix will fetch it just like the distro that you have.
I don't think that was what I said. Oh, I'm sorry. I should have given you the other microphone.
Oh, that's okay. So, what you're trying to say is you can fetch it under any Debian-like system?
Citrix specifically has its own scripts for doing so, for fetching the kernel and patching them with its own patches. The reason we are using Citrix is, first of all, the kernel version in this release is one to which the patches that I submitted for the previous card have already been applied. And the other reason is that the kernel as used is this easily well, for lack of a better word, sourced, so not in the usual sense of the word, and
The same kernel can easily be gotten again.
yes, this, well, yes, the kernel that is used in here, and there are not that many patches in it. It would have been preferable, perhaps, to use one with even fewer patches, but the kernel version mattered too. Now, let's start a shell here. Can everyone see this text, or should I make it bigger?
You
Bigger.
should definitely make it bigger. Also, I'm noting that I'm typing the text of some of what you're talking about into the SVLUG IRC channel.
Thank you. Let's see. Font. Okay.
Yeah. I can make a lot of it.
Select.
Have it cut off.
Okay. Well, that's 11. Let's try 18. Is that big enough?
Very good.
Thank you. I'll widen the window a little bit. Okay. Now, I believe the script is in user source. And it's the only file there with a .sh extension. And I am not sure whether it requires super user privileges or not, but let's try running it. And see what happens. And it apparently does not require it. Saves us a bit of time. Unfortunately, there is no progress indicator for the download because it is downloading the kernel source right now. I'm hoping. Yes, the Wi-Fi is blinking, so it is.
ls-l/10. Daniel, while that's unloading, could you get up another shell window and maybe just cat out the script so we could see what's in the script?
Oh, that's a very good idea. Thank you, Darlene. Oh, I need to make this bigger again. That's for the whole screen. Okay. This script is not particularly short, so going through it will take longer than the download. Let's see if that's done. And it is not. Okay. Now it starts with the shebang, as we all know, and the brief license header. It sets the initial variables. And it's still doing that here.
One note for those who don't read a lot of shell scripts, that -E on the shebang line is a switch to bash that says on any simple command that gives an error, exit the whole script.
With an error.
Yes.
Okay. Now, here is a function that has a list of the patches to be applied. And Here's a usage function here. And here's the getOpt section of it. I did not know this was in here.
What's in there?
Gimpelevich.
Oh, yeah.
Very professional comment.
Yes. Various shell scripting here to find the correct kernel to use, because of course the script is used unchanged among different kernel versions in the same distro for different releases. And also providing the source to the patches and the script right here. Here's the actual patching. And here is the main section of the script. I don't suppose anybody has any questions about the script. Now, as you can see, it has downloaded and it has patched the source, and it says that it is prepared. Now, we will not, it's changing the kernel version string. We have to fix that. Okay.
Back to what it was.
Yes. Now, very likely this will be in the make file. And as you can see, it is right there under extra version. Now, the one we are actually using is this. So we will take it from here. It's hard to look up while I do this. And that should take care of that, at least partially. Bruce is referring to the kernel version release name, which is right there on the screen next to name. Every version of the kernel, every release version of the kernel has a different string there.
Pop that back up again a moment.
Oh.
Harry Bildrat?
R. Matey, a hairy bilge rat, is the current name used in this release of the kernel. Now, since we will be dealing primarily with kernel modules, and the core of the kernel itself will not change, we need to get the module symverse file that was created when the kernel that is being used was built. Now, I'll take a wild guess and take a look inside a user source and see if we can find a copy of it there. And there is a directory in here that begins with the name Linux headers that is usually used for building modules outside of the kernel tree that has headers but not actual kernel source. And we may simply use this directory if it works, and if not, then we may use the one we just had prepared. As you can see, the module.symverse file is in here. And if we want to duplicate the usefulness of this directory with an actual kernel source directory like we have just paired, we will need that, and we will need the kernel configuration. Now, if I show all of the files in that directory, it may be in there. And as you can see, it is .config right there. Let's start by copying both of those files here. Now, that is not the only thing to be done. Whether we use this directory or that one, the directory would have to be prepared for compilation of modules. We will do that a little bit later. Now, there is a command called modinfo that, when given the name or path to a kernel module file, will provide some information about it. Now, the kernel module that would be loaded for the particular PCI card that we will be using is the one for this chipset. But there is more than one such module there. They are interdependent, and module dependency version information is also displayed with the modinfo file. Modinfo command, sorry. And let's try the modinfo command with one of these modules. directory. It helps if the command is in your path.
You'll also need to move back into your correct directory.
Not for the modinfo command. Now, this is the display for one of these modules, and it starts with the path name, lists its license, its maintainer, not necessarily the only author, the description. This is Video for Linux second API, and the rest is self-explanatory. I do not know why it lists the module of the license twice.
So that's the mod info of one of the drivers that does work that's similar to we want to use?
This is the mod info of the of one of the drivers that we will be dealing with. Now, the depends line is what shows the modules that this module depends on. In other words, modules that must be loaded prior to loading this one, which nowadays happens automatically. Usually. You can control that to a finer grain of detail if you need to, but we will not be doing that tonight. The vermagic line is why we edited the make file. If this entire string does not match between the module and the kernel, the module will not load without a force flag. These are various module parameters that this module accepts. There is something also missing here, and that is the alias lines. That means that this module will not be auto-loaded in response to the presence of any hardware. However, the other module depends, as you can see, on the first one. And it has an alias line that begins with PCI : indicating that PCI identification information, upon matching, would signal UDEV to load this module. And, of course, the depends signals then to load the other one and all of these others. Now, in here, you can see a hex string, which includes the vendor ID and the product ID for the PCI card. V starts the vendor ID, and the rest is, of course, the product ID, beginning with D for some reason. Now, we can try taking the card right now, putting it in, and seeing what the kernel will show us. I'm sure you all know about the command called dmessage. Now, right now, without the card, it will show a bunch of information about how the kernel is responding to various hardware and modules that are installed. I'm going very quickly past here because a lot of this is not particularly relevant, although some is, and there is a lot of it here. Now, let's take the current output and put it in a file. Oh, let's put it in the home directory. we can compare what dmessage will say later to what it says now. This is a box from a store, still sealed, with the card that we will, the card in question that still with everything that comes with it, because the seal, as you can see, is still here. We don't know exactly what's in here, because, of course, it is slightly different from the card that I mentioned before. But we have a pretty good idea. And we don't really need to know that which we do not yet know. I'm now opening the seal here and opening the box. Now, box is open. Nothing up my sleeve. In here we have the card. We have some documentation, apparently. We have 2 CDs, apparently. And we have the dongle that goes to the back of the card that breaks out into multiple cables. Now, in here, of course, is the card. Let's ground, and this is what it looks like, an ordinary PCI card with a big sticker that covers an unused portion of the printed circuit board. In the back plate, there is a single connector that fits the breakout dongle. Now, let's shut this down, of course, because PCI cards are not hot pluggable.
Not if you want them to work.
Exactly, Larry.
It's the motherboard that's not hot pluggable.
Well, of course, putting a PCI card in takes very little time, so we can afford that right now.
Warning, attempting to hot plug consumer PCI devices lets the magic smoke out.
Could we please pass the other microphone around?
I said, warning, trying to hot plug consumer PCI devices lets the magic smoke out. It was just an interlude commentary.
By the way, I forgot to mention, if any of you have any questions at any point, please interrupt me while you still have the chance. Microphone.
So I have a question. What is that file, module.simver? What's that file for?
Module.simverse is a text file containing the relocation addresses of various symbols used in the kernel and modules already built to which modules you wish to build may refer so that it can find them. If you do not have this file, when you build modules outside the kernel tree, then the modules you build will not know anything about dependencies or versions of neither the kernel nor the other modules. A side effect of this is that modules upon which your module depends will not be loaded automatically, even if the rest of the mechanism to do so is there. card is going in. And unfortunately, I will need a screwdriver because the wrong slot cover is off.
Might be threaded fasteners as well.
Not yet, but what I will need is there we go. That was unexpected. Yes, yes. There's this. Should be good enough. We will turn the machine back on. Well, it has to be slower the first time you boot it with another PCI card because the BIOS updates the ESCD data, and well, okay, 4, right?
Correct. Did it detect the other signal?
I think so, yes.
Do the huge penguins mean something clever like 2 CPUs?
Yeah.
Larry has a good question that I would have assumed was already
I'll
well
go ahead and
known.
repeat the question for him. He said, does the number of penguins during the initial boot up actually signify anything like the number of CPUs?
Thank you, Jim. And the answer is yes and no. If you have one
Nothing like being definitive
CPU
there.
that appears as one CPU, then you get one penguin. If you have 2 CPUs, each of which appear as one CPU, then you have 2 penguins. If you have one CPU that appears as 2, then you have 2 penguins. And if you have 2 that appear as 2, then you have 4.
I think the short answer is if you cat/proc CPU, there should be 1 penguin for every one of the lines in there that says that it's a separate CPU, virtual or otherwise.
That is correct.
So if you don't have an SMP kernel running on n CPUs, you will see 1 penguin.
That is correct also. Let me repeat. If your kernel does not have symmetric multiprocessing enabled in its configuration, then you will see 1 penguin regardless. Now, right away, we have an interesting message here that something is gone wrong with the sound. This may be due to the card, or it may not. One thing that we should take a look at to see whether it is due to the card or not is proc and apparently there is no longer a proc A sound.
Might be under sysfs now.
Yes, thank you.
He might be looking for something under /sysfs, /sys.
Well, sysfs is organized differently. So let's take a look at this another way, shall we? Let's take a look at which modules are already loaded and see if there is anything in there that, that looks like sound. Now, there does not appear to be anything so far. Something you will notice here is that the modules for this card have auto-loaded. We will re-examine that shortly. But it would appear that there is nothing here related to sound. This could be due to having the sound card in the adjacent PCI slot. One thing that we should take a look at whenever inserting an unknown PCI card is LSPCI. Now, we notice here that the last item is the card we just put in. Now, as you can see, what we see first is the chipset. It is common in not only video capture cards, but several other types of PCI cards, for the vendor and product ID of the card to be that of the chipset, which is very convenient under Linux for figuring out what it is, and then a subsystem with a vendor and product ID of the actual card. Now, this address of the card on the PCI bus, we can specify to LSPCI with -S, and it will only show information about that one. The reason I show this is because if we do this verbosely, we also see the subsystem, which apparently we are not seeing here because the access is denied since we are not root. However, since LSPCI is in our path and I've already set up sudo but not with no password, we see that it lists capabilities here, but it is still not showing any subsystem. This could be for lack of having one that identifies itself, or we might need more verbosity. And here we have more verbosity, and we still do not see a subsystem. This would tend to indicate that this card can only be identified by its chipset, and that the machine will not be able to see anything, any identification information on this card beyond that. For contrast, let's go back to the big list. And let's find, where is that sound card? And interestingly, the sound card that was shown here before is not appearing. This is unexpected and may create a slight detour for us right now. Let's take...
Mind if I ask a silly question?
Okay.
Is there any possibility that you physically dislodged it from its slot while you were inserting the other one?
It would appear that it is not dislodged, at least visually. Warren?
I don't actually think it's dislodged.
Okay.
Maybe
Just thought I'd ask the silly question, is it plugged in?
I was thinking the same thing.
That is a very good question and one worth examining. However, before we do so, let's take another snapshot of dmessage.
How about bad sound?
Okay.
You
No
don't want that
space.
space in there, I don't believe.
Oops.
Spacing out is no fun.
Okay. Let's do a quick unified diff of them and see how much difference there is. First difference is inconsequential. It's a slight variation in the CPU clock speed. Same for the second difference. And the third. And the fourth. Then comes something that might be interesting, and that is that interrupt request lines are shown slightly differently, except not really, because they're just shown in a different order. That time. This time, over here, with this difference here, there is another difference, and that may or may not be due to inserting the card.
What does the LNK1, LNK2, all of those little things in the square brackets, what do they mean? Because there is a difference up there on those first 4 lines.
On the first ones?
Yeah, the link 1 and the link 2 are...
No. Oh, yes, you're right. These are links between the interrupts on a PCI bus as recognized by the ACPI system. ACPI is Advanced Configuration and Power Interface.
So does it not matter which order they come up in?
It may matter which order they come up in, but we are not yet interested in that.
Okay.
And we may not be. There are more differences here in terms of system resources, but nothing that is especially interesting to us yet. I should probably have started at the end because, oh, let's go to the end now. Many modules, upon loading, put messages in dmessage. Now, in the old dmessage, we see here messages from the sound card driver that we do not see now. And we see now messages from the capture card that we did not see before. And a lot of them, let's start with some of the first. Should have showed this right away, probably. Now, as you can see, it says your board has no valid PCI subsystem ID and thus cannot be auto-detected, which I believe I explained. This is the module saying this to you in case you did not already know from LSPCI. And it is asking for one to please pass card equals a number as a module parameter to tell the module which of the cards in the list it may be. Now here is the list of cards as supported by this version of this module. 0 is unknown and or generic, which is the default.
19?
16.
Um,
World card there.
19.
Bruce is pointing out that card number 16 is of the same vendor, as is card 14, as this card. But as you can see, one vendor may have more than one card in the same module because the cards are different from each other. Now, if we go a bit further, we get to the end of the list down here. And after the end of the list, we see that it has auto-detected it as unknown and generic. Now, since this version of this module has not had many modifications to it after the patch that I submitted for the previous card was applied, that card is the last one in this list, number 57. Now, it is reasonable to expect that perhaps if we just told it card equals 57, that it would just work. However, we will take a look at why. Before we do that, we should probably make the sound work again.
Might sound just work on reboot?
Bruce is asking if a simple reboot might make the sound work. Now that is plausible in combination with what Jim suggested, especially since when looking inside this case, it seems that the PCI slots and the board, the motherboard, are not well aligned, so perhaps we should do that.
If you shut it down, I'll reseat the card if you want to say anything while it's going on.
That is a good point. However, the kernel command line is primarily useful when a driver is compiled directly into the kernel and not a module. Since we have already seen the output of lsmod, we know that it is a module. So, one thing at a time.
Actually, on that last point, I'm kind of curious because it's something that I don't actually know the definitive answer to. If you put a option on the command line, then, of the kernel's command line, it's preserved throughout the kernel sessions under /proc cmd line. And I actually wonder if modules check that in the absence of mod probe arguments to them.
The kernel command line?
Yeah, there's
do
any
not.
reason they couldn't.
Except that they do not.
Okay, I wasn't sure one way or the other. And it's not something that I could easily think of a quick test for.
However, in some distributions, the initRD and or initramfs has scripts that will parse the kernel command line and then pass it in some way or another to modules. Usually only modules that are in the initRD and or initramfs, with modules that are not in there getting their kernel parameters elsewhere.
I suppose
Warren
another
has
place
just
it
said
could be done.
that he has reseated the card, the sound card, not the capture card. And he is now confirming what I observed earlier, that the card did look half in.
So while we're waiting for that, I suppose it is just vaguely possible that a version of mod probe could also check the kernel command, /proc cmd line to pass relevant arguments to it if it wanted to do some magic. Kind of similar to how the mount command will scan through /proc partitions to figure out what your volume labels are.
Jim is correct. It could do that. However, I personally have not yet seen a version of mod probe that does.
What if you have the same parameter for two different modules? How do they know if
That is a very good question.
That's probably why it doesn't do it.
Well,
That is a very good question, which
Okay.
I shall now answer.
This gentleman mentions, what if you have conflicting parameter names? And actually, they have a way of dealing with that because you can then prefix the parameter with the module name, and those have to be unique. So you can say something like CX888880 dot IO port equals, or IO reserve equals, or whatever.
So if it's on the kernel command line and it's not prefixed, you cannot be sure it was meant for you.
That would be true, but I'll go ahead and let.
The other thing that you have to
Daniel,
know
take it
is
over.
that the kernel command line has a certain fixed length, which is another reason for using modules as opposed to the kernel command line to set those types of things.
Yes, if the modules need parameters.
Right.
Jim's answer is, of course, correct. The module parameters, when compiled into the kernel and put on the kernel command line, need to be qualified with what would otherwise be the module name and a dot. Only parameters that are interpreted directly by the kernel and not by anything that could be a module are missing the leading name with the dot. Now, as you can see, this time there was no message saying anything about sound, so it's probably working. I see Warren did not plug the cable back in.
Sorry.
Oh, he did, except he plugged it into the wrong connector.
No. Oops.
Okay, so let's. And I forgot that closing the terminal will mean that I need to make the text bigger again.
One of the online people has asked when we're going to get to see the kernel code.
It may take a while because I did not expect the card not to have a subsystem ID, because if it were to have one, then we would have obvious data to put into the kernel code. Without that, access to the kernel code is less, the need for access to the kernel code is less immediate.
So what you expected was for it to have a subsystem ID that was poorly recognized and therefore.
Could someone please give Heather a microphone?
Like the one in front of her.
So what you expected to see was for it to have a subsystem which it didn't recognize correctly.
That is correct, because that was the case with the previous card. And not only for that reason, but for another reason which I will not get into tonight. Now let's take a quick look at OSPCI. And we see that the sound is there now, but that the capture is not. Whoops.
Did I knock it out?
Let me take a closer look here. Yes, he did.
Sorry. This is why I'm not a Geek Squad.
So, on tonight's YouTube video, seesawing your cards in and out, up and down. One goes in, the other comes out.
Who didn't put all the standoffs on this motherboard? The thing's like rocking back and forth.
Are we ready? Okay.
I am not repeating that. This is a PG rated, excuse me, this is a G rated video, pal.
Shame on you.
This actually is the first time that has been run with any cards in it. This project, anyway.
This board?
Yeah, that motherboard, I've never had a card in it.
Bruce is pointing out that this motherboard has never had any PCI cards in it at all before, ever.
I'd like to point out the fact
I noticed that the portions of the case that cover the slots that need to be punched out were still there for the slot which it's in.
I would like to point out also that I had to put my fingers under the motherboard to hold it in place to shove the card in as I shoved the card in. So.
Well, that could have been done from the side, but
yeah. I'm just saying, very clearly, never had a card in it.
Yes, I did not put this board in this case.
There are some standoffs missing
or
down
did
there.
I don't remember.
Yeah, see, there's a standoff missing right there.
I do see that now, yes.
Yeah. All right, so
Okay.
we ready?
Yes.
All right. Take 3.
Well, that was a colossal waste of time.
We're going back to basics.
Yes, maybe you should give Larry the microphone so that he can repeat that.
I said we are learning the important lesson of checking your work.
This is an inevitable consequence of not knowing what will happen.
It's amusing to see the phrase, this may take a while, zip up the screen though.
Yes, yes. Heather is pointing out that some strings that were put into the kernel were put there when machines were much slower. Take 3. And here we have both the sound and the capture.
But we're missing the video card.
All right, I say we give this
Just
man a
kidding.
round of applause.
The video. Well, I didn't notice who said that we're missing the video card.
That was a joke.
But it is true, we are missing the video card. But but we're using the onboard video anyway.
Actually, I see VGA compatible controller. That's not
That is,
the card,
that's
though.
the
That's
onboard
built-in.
video.
Okay.
We're not sure why the card that is in the slot is not showing up.
Probably because it's no longer in the slot.
0105.0 multimedia video controller.
You're right, it is not in the slot.
That's my bad.
All right, carrying on.
Okay. Okay, now, okay, now, one thing that may take another reboot is that right now, again, it has found the capture card as unknown and generic. And if we change what it auto-recognizes it as by forcing it to a particular card number with a module parameter, we may want to see it work automatically after this is done, but we're not there yet. Let's take the dmessage currently. There will probably be fewer differences between this one and the first. And one of the first substantive differences is what I showed before, that the driver is complaining that it does not know which card it is. Now, like I said before the seesawing, let's take a look at why this card may or may not be sufficiently similar to card number 57. Of course, most PCI cards have Windows drivers available, which are typically intended to work with those cards. So it's reasonable to expect that if a Windows driver works with a card, and we can see what the Windows driver does that is specific to that card. What was that?
Did the microphone fall?
I don't think so. Now where was I?
Looking at Windows drivers and what they do.
I mean, where in the sentence?
Just start over. Yeah. There are Windows drivers. They
Okay,
typically work with their cards.
Now, if we can see what a Windows driver does that is specific to that card, we may be able to duplicate this under Linux. Now, let's take a look at the portion of the kernel tree that has the source for this module in it. Now, remember the modinfo command. Now, when we do a modinfo on the module in question, and we need to be root, or we need to supply the path, sorry, then we can see that the path has in it a path where in the kernel source tree this particular module source will be found. As we can see, it is under drivers, media, video, and then CX88. So let's change directory into that path, beginning with the directory where we have the source. Drivers, media, video, CX88. Now, this chipset, which for the purposes of Linux is collectively known as CX88, all of the different chips in all of the different variations of chip that are in this family, which are CX88, 882, and CX88, 883, 880, 881, and so on and so on, have their own set of source files together, which are in this directory. And here are the source files. Now, as you can see, the Citrix distribution has already patched one of them, and apparently, we don't know for sure, but it's a reasonable guess, and the unpatched version is there alongside it. You can see this right here. Now, taking a look at the names of some of these files, there's one that should jump right out at you. CX88 cards.c, because this is the file where the differences between the cards are kept. Now, I'm going to use VI rather than less so that we get syntax coloring.
You could use view if you don't want to actually edit it.
That is true. You can do that. Now, of course, it starts with the description, copyright notice, and license header. And of course, the standard things that go at the top of a .c file, such as the #include statements that are specific to this file.
Can you briefly describe what each of those .h files is for?
Well, they are specific to the kernel and getting more specific as to modules for the kernel and modules that involve PCI, and of course routines that are used in the file. And of course, there is one that is that has the declarations common to the .c files in this directory. You may have noticed that you did not see this file in this directory because it is in an include directory. Now, this should look familiar right here because we are seeing the source of that list. There are the settings for unknown and generic And there's the settings for card 1 and card 2, and so on. Let's go down to the last one, which we are more than likely most interested in. Appears that they are, okay, it goes beyond that. Okay, now this particular one has settings here. Now, this is a constant that is defined to be 57 in the other file, in the .h file. And that is where we get the card equals 57. And it's here like this because this is array element number 57. And the array element is a structure. Now, of course, when a structure is in an initializer in C, you may simply put the values for each member of the structure in there in curly braces in the order in which they appear in the structure. But who gets to remember what order they're in the structure? So you can do them by name, as long as you put a dot before the name and an equal sign after. And some of the fields that are used in the structure defined in the .h file are name, tuner type, radio type, tuner address, radio address. Name is, of course, how is a human readable string of the card, how it's printed on the screen in dmessage and elsewhere. Now, capture cards often include television tuners and or radio tuners, which, if present, would be described by these four structure members here, which are here set to what they, the values that signify that there's nothing there, because it is a simple capture card. Now, you notice that there are 3 inputs defined here. One of them is labeled debug, one of them labeled composite 1, and one of them labeled SVideo. And there are different video multiplexer values for them that identify where the video comes from. But then there is also a value for general purpose input-output, which does not look like it means much. And we will get to that in a moment. But before we do...
Online it is asked, these fancy names in capital letters with brackets around them, are there some sort of preprocessor defines, or?
I believe I already said that. I believe that I said they are defined in the cx88.h file, and the one we're looking at here is defined as 57. Just as we saw in the list from dmessage, it said card equals 57 for this card, and they are indices into this big array of cards, of possible cards. And I will actually now show the cx88.h file itself, and before we get back to here. I'm sorry, the cx88.h file is in the same directory.
Hello?
Yes?
You could actually tell that it was in the same directory because it was in double quotes as opposed to the angled bracket, the greater than, less than.
This
That-
is
that
correct.
means- that
That is
actually
the
means that
convention.
it's a convention, so
That
it's
is
not
the
necessarily
convention, but
always true, but you should be
that
able
is the
to.
convention. But when using double quotes, if it does not find them in the directories that are for double quotes, it searches them for the directories that are for angle brackets as well.
I was just pointing out that it may be useful to, to know that convention, though.
Here we have some constants defined that are used as values in the structure. And let's see if we can find ones that we have seen. Now, here we see the ones that were just asked about online. And as you can see, they are the same numbers that we saw in dmessage. If you were to add a new card here, you would make another one of these constants with the next number. Now, here is an enumerated type that has the various input types named off: composite 1, composite 2, composite 3, composite 4, S-video, television, cable, DVB, debug, and radio. And then here is the input structure that is the last element in the bigger structure that we saw earlier. And you see the same member names here, except that you see 4 different general purpose input-output members, because this particular chip family has 4 different general purpose input-output registers. And here is the bigger structure we saw. As you can see, there are 2 input structures in it that are defined above. One is an array with the various inputs in the card, and the other one if there's a separate radio input. Now, if a card has MPEG encoding capabilities, which this chipset does support, it would be signified with values in this structure member. And something that I haven't showed yet is the breakout dongle that came with this card right here. Now, this has one plug that plugs into the card, and of course, the stereo audio inputs, one input for composite video, one input for S-video, but what's this? Many capture cards, upon taking the audio input in through here, send it to the card, and then back out through here and into the sound card. However, some have the additional input, the additional capability of sending the audio from the card directly to the software. And if this is present in the card of this chipset, this structure member here would describe that. And of course, this is a structure here that that would be used to identify the card by its subsystem, vendor, and product IDs. And there are additional structures in here that deal with the internals of the specifications of this chipset and driving this chipset. Which we could concern ourselves if we find problems with the chipset as it is driven regardless of which card is being used. But this is a very mature driver, and we don't need to concern ourselves with it in this case. Now let's go back to this file where we were before, and we take a look at this array element again, this time having seen what we saw there. Come on. Okay. Now, we saw that there were several different types of inputs possible, but only 3 are being supplied here, each with a different video multiplexer identifier. The video multiplexer identifier is what you tell the card as which input to use. The ones that say type is how the driver interprets what it gets from the card as a response to that particular VMUX. And the general purpose input-output we will still get to, at least for this chipset. After we're done with this card, I will have more comments about that.
We only have about 5 more minutes, so I doubt that you're going to be able to get there in that. So,
well,
could we get to maybe
let's see what we can get to.
Well, could we get to maybe a stopping point so that we can continue next time? Would that work?
That might be a very good thing to do, but
Okay.
let's see what we can get to today.
All right.
Now, I mentioned that we may be able to see what the Windows driver does that is specific to this card. Now, if you look at the cards above, you'll notice that a lot of them are very similar, but the one thing that doesn't look similar in most of them are the values for the GPIO. As a matter of fact, if you look through the entire array, you may see cards that are whose entries are identical in every other way except for the GPIO. And indeed, there are no other cards with these GPIO values in the array. Now, let's boot into Windows for the moment. And of course, Windows will detect the new card and spend about at least 30 to 60 seconds supplying software for it. And I just remembered that the particular software that has the driver for this card refuses to install itself unless the card is there. So that still needs to be done. But, well, enjoy your next 5 minutes then.
I think that this might be a safe breaking point because I think it's going to take about as long as this.
Warren is correct.
So I think this is going to take us up until the point where we have to break. Will you be able to continue next week, or?
Yes, I expect that I will.
Okay.
I did not expect that we would do so much back and forth of things that we did not expect. So,
well, Well, I think that it's,
Yes.
you know, good to see it actually happening so that everyone
Yes.
knows what to look for. Well, could everyone give Daniel a round of applause for standing up here and doing this for us?
Thank you.
And I guess we'll shut this down. Maybe next time, make sure all the cards are nicely seated and bring it back and play from there.
Since the card is now in the machine, we can actually take this opportunity to prepare it for next time.
Right.
And I will take a quick, I will make a quick point before we adjourn that there is, well, I may not be able to make this point, but I'll try. There is an icon here, shortcut to regspy. Regspy spies on the contents of registers in PCI cards, particularly capture cards, including general purpose input-output registers, so that we can look to see what is in the register while we do various things with the card. And we will be seeing that next time. RegSpy is no longer a separate download. All current versions of it are part of the download of Dscaler, DSCALER, which is at dscaler.org.
Is this an open source application?
Which is a GPL'd Windows application that is also available for Linux that does something that we're not immediately interested in, but RegSpy is included in the download, or rather in the installation.
Thank you very much.